So we're throwing more fractions into the mix with this problem. The process is still the same. Isolate the squared term, use the square root property. The difference is that we have a fraction that we're taking the square root of, and we need to remember we can take the separated into the square root of the numerator and denominator in the process of solving. So if we have x minus 1/2 squared equals 5/4, squared term is already isolated, so we'll just invoke the square root property. So this equals plus or minus the square root of 5/4. X minus 1/2 squared, taking the square root, we get x minus 1/2. Now with this, 5 is not a perfect square. 4 is. So we separate this into plus or minus square root of 5 over the square root of 4, which is just 2. Now we add 1/2 to both sides, and we get x equals 1/2 plus or minus the square root of 5 over 2. We could factor out the 1/2, but we're not going to do that. We're just going to leave this as x equals, we're going to put it over the same denominator, 1 minus the square root of 5 over 2, or x equals 1 plus the square root of 5 over 2. Now let's check our solutions. Substitute into the original equation. I'm going to use brackets because we have a fairly large solution if we're not taking a decimal approximation. So 1 minus the square root of 5 over 2. So let's write that first. 1 minus the square root of 5 over 2 minus 1/2 squared. We want to know, does that equal, I guess I should have written it this way if I'm going to do it syntactically correct. That was the point of the of using the bracket. We want to know, does that equal 5/4? So let's simplify what's in the brackets and parentheses first. We have 1 minus the square root of 5 over 2 minus 1/2. Well, that's the same denominator. So we have 1 minus the square root of 5 minus 1 over 2. The ones cancel. So we just end up with negative square root of 5 over 2 squared. We want to know, does that equal 5/4? Negative square root of 5 squared is just 5. 2 squared is 4, so this is a true statement. 5/4 equals 5/4. Now we'll check the other solution, 1 plus the square root of 5 over 2. Same process, 1 plus square root of 5 over 2 minus 1/2 squared. Does that equal 5/4? 1 plus the square root of 5 minus 1, it's the same thing. We just end up with a positive square root of 5 instead of a negative. So square root of 5 over 2 squared, does that equal 5/4? And again, it's the same problem. We'll go ahead and write it out this time. Square root of 5 squared is 5. 2 squared is 4. So 5/4 does equal 5/4. Verifying that when x minus 1/2 squared equals 5/4, x equals 1/2 plus or minus the square root of 5 over 2. Could write this as 1 minus square root of 5 over 2, or 1 plus square root of 5 over 2. Could also write this as 1/2 times 1 plus or minus the square root of 5. Or 1/2 times 1 minus the square root of 5, or 1/2 times 1 plus the square root of 5. Any of those would be acceptable if you're looking for an exact form of a solution for the equation.